Hey guys, so a number of you have asked me to do a video about wiring up the headlights on this XR400. I put like a 30 watt or 45 watt, maybe it's 50, I can't remember, high beam headlight on here, and then I put a light bar on. I'll put a picture up of what it looks like. When working on this stuff, I highly recommend picking up a service manual for it. I picked up this one off of eBay. This bike is a 98, but this is a 96, 97, and these bikes are all pretty much the same. So there's a wiring diagram. Put this up here so you can see it. This is the alternator, or the stator. In the manual here is called the alternator, and the alternator has the coil of the stator in here, and there's also an ignition pulse generator, and the ignition pulse generator feeds the ignition control module that sits here, and lets the coil know when to fire the spark to the spark plug here. So the components that were on this bike, or that are on this bike, if yours is still like new, you'll have an AC regulator here, which looks like this component here. It's got a plug, and it just this rubber piece just holds it right here. I took this one out because when I was working on the bike, I realized that the previous owner that put a Baja Designs light kit on this left the AC regulator in here, but it wasn't actually doing anything. The power that connected to it that would drive it wasn't connected, and the ends that went to the lights were not connected either. It was just hanging in here, so I took it out. So yeah, this bike did have a Baja Designs light kit on it. That is, it was standard, the AC powered headlight, or wait, no, it's DC. Baja Designs uses DC, I believe. So what the previous owner did was, there's two wires here, a pink and a yellow, that come up. I'll see if I can get a close-up of this. You have the wires that come out of here. There's some red ones, these are not used here. There's pink and yellow that went to the AC regulator previously, and they cut those, you can see here, and put them into these two yellow wires, and those two yellow wires feed a rectifier here. The rectifier, if you don't know, converts AC power to DC power, because LED lights run off of DC power, and a lot of motorcycle lights do as well, but you can buy AC powered lights as well. So the previous owner had the rectifier installed here and a battery pack, which still works. It's kind of messy looking, but it still works, which is why I haven't replaced it yet. And I initially put a LED light on this bike, and I noticed that I blew it out. It blew out, and I was trying to figure out why. LED should be fine, and then I got thinking about it, that the rectifier, well, I thought this regulated the voltage, the DC voltage as well, which it doesn't, and the voltage coming off of this rectifier was like 25, 26 volts, which is way too much for the LED. The LED is rated for 12 volts. So it was super bright, but it burned out pretty quick too. So what I ended up doing was putting a DC voltage regulator in here, and I noticed that the LED would also flicker a lot with the pulses of the engine, so I put a 4700 50 volt capacitor in here to smooth out the power delivery. I thought about doubling up on it, and I might still do that, but I haven't yet. And don't worry, I'll go into more detail on the wiring, like how the wiring is done here in just a second. But I wanted to run over, based off of the manual, how it originally was wired up. So originally the pink and let's see here, the pink and the yellow wires will run to the AC regulator. The AC regulator has a green wire, which is ground, and it has a white with a yellow stripe, which feeds the positive, which goes to a blue wire, and the blue wire will feed the headlight and the tail light. And then you'll also have, coming off of the ignition control module, you'll have brown and the black with a red stripe, which will feed the power to the ignition control module here. And there's a black wire with a white stripe that runs up to the front here, and if you hit the kill switch, it basically connects. It's a switch that connects that black with a white stripe wire to ground, and that will kill the engine. That shuts off the ignition control module. So right now I'll go ahead and walk through how I wired it up and take it step by step there. So. Okay, so now we're looking at the left side of the engine. You've got the stator behind here, you've got the cable that runs out and up and around here. And this is the wires that come out of the stator. So move this back out of the way here. So the pink and the yellow wires here are the ones that go up and feed. They're one side of the one coil off the stator, and these run up through here and into the rectifier up here, which we'll get to in a second. Then this is the brown and the black with the red wire that come out of the, let's see if I can zoom in a little bit on this. So here we have the black with the red stripe and the brown wire, and these go into the ignition control module here. And then this is the one that comes from the ignition pulse generator, and that feeds the ignition control module as well, so that you know when to, or when it lets the controller know when to fire the coil. And then we also have this black with white stripe, and that's the one that goes up to the kill switch. And then the green wires are ground. So these red wires are not doing anything. They've been capped off. I'm not sure exactly what those are for. So now we're going to jump to the top view. We'll take a look at the regulator and the rectifier and stuff up here. Okay, this is the top-down view. Looking under the seat here, you can see the yellow wires here in the lower left corner that come up from the stator. They feed into these two yellow with black stripes, which, since it's alternating current, it doesn't really matter. And those come up and around here, and they tie into this rectifier, the two AC lines here. Now the rectifier, since it converts AC to DC, the yellow is input, the black and the red are output. The black wire here goes to ground, and the red wire comes off, and this is just converted to DC. It's not regulated at this point, meaning that it's still 24 volts, and this goes into this connector, which goes to the battery and recharges the battery. Then you have it turns to black here in this connector, runs through the fuse in case we get a short, it won't blow stuff out. And this, so the power comes here and it goes around and up into, I don't know if you can see this, into this connector here. Now this connector, this is still just unregulated DC voltage, and this runs into this capacitor. This is a 4700 microfarad 50 volt capacitor, and it also grounds out as well, so it stabilizes the power delivery going into our DC regulator here. So it's connected in parallel here, this red wire. So the red goes in, And then this, in my other video that I did on installing the bike light, I talked about this DC regulator more. Voltage goes in, I believe I have it set at 12 volts, maybe 13, I can't remember. Then the yellow comes out. Yellow is the regulated power at this point. So this going in should be like 24 volts, 25 volts, and the yellow coming out will be the regulated at 12 volt. Now from here, it goes into this blue wire. This is the blue wire that was here previously. And this connector, this wire harness here, let's see if I can get it out. It runs inside this harness, comes up, and then goes back inside here. Okay, just a clarification here. I thought I'd show you the wiring diagram real quick. You can see the yellow coming off the voltage regulator here. The yellow plugs into the blue, which is how it is under the seat. That blue line runs all the way up to the front handlebars, which is where the multifunction switch is. If you don't remember, this is what it looks like. And then from there, the wiring harness runs back through the through under the seat there and back out to the tail lights. Now, one thing that's not shown in the wiring diagram here is that blue wire is also in the same harness as the red, green, brown, and black wire. It was just clearer to lay it out this way to show it and to clarify. So, all right, we'll jump back in now. Now from here, this part, this is what's coming from the handlebars, and this goes back to the tail light. So if you look here, let's see if we can see it here. There is a red wire. The red wire is the tail light. The brown wire, if I remember right, is the left-hand turn signal, and the green is the right-hand turn signal. There's also a black wire here and a black wire here. Both of these go to ground. This one feeds the tail light, and this one feeds ground up to the handlebars. So that's how this is wired up. Now what I'm going to do is reset the camera and take a look at the wiring up here at the handlebars, and we can talk about what happens up there. Okay, now from here, the power that runs up to the front comes through this cable here, and this cable runs into this connector here. Now the red is switched power from the main switch up on the handlebars, and the green here is the right-hand turn signal. I'll see if I can zoom in on this a little bit. Okay, this green is the right-hand turn signal. The brown on the opposite side is the left-hand turn signal, and the blue on the bottom here is the power that's coming in from the battery. And this connector here, this is a pigtail. Let's see here. This is the connector from the main power switch up on the handlebars. So its power in is this gray wire here, and the power coming from the battery is this blue wire. And I cut this recently, or just a few minutes ago, because there was another wire coming off of this that I didn't need, so I still need to solder this together. So this connector here, like this green goes to the front turn signal, this brown turn goes to the other turn signal, and they are both feed the rear as well. This red wire here is power that is switched. So the main switch, when you can turn on parking headlights on the main switch up on the handlebars. When you kick that on, there's power to this, which goes back and powers the tail lights. It also has this purple wire that runs into this other harness here and provides power to the horn. And it's also joined with this other red wire here. Let's see. No, that's the horn wire. This red wire here is the horn. This red wire is the one that runs into the turn signal. So this has power to the turn signal, the blinker, and the orange. When you flip the switch up on the handlebar, then this provides the intermittent blinking power, and the turn signals are grounded out. So yeah, you've got the horn here, we've got the turn signal. This is the other wire that's coming in from the ignition control module, and these two wires are what allow you to kill the engine via the kill switch. Now I have two switches on here. There is this one here that goes to, I have a key, so it will automatically, or it'll always keep it locked, or well, it won't let you start the bike because it'll always ground out this black and white wire. And then I have a kill switch on the handlebars as well, which is what these two wires run to. So I'll talk a bit more about this connector here. This connector is the main power distribution coming from the handlebar switch that has the headlights and the horn and the turn signal. On this connector we have this peach wire on the back here. This one is the horn switch. So when you connect that, if these wires were connected, then when you press the horn button, this would get grounded out and your horn would work. This yellow wire on the other side of it is a high beam headlight, and this went to, oh, let's see here, it's coming out on this, on the bottom here. So these two, they don't run to the back because the high beam and the low beam are only on the front, right? So these run around to the connector that you can plug in the high beam on. The black wire here is ground. So those are the top three. The next three is blue, which is the power in. So blue is power in, green is right hand turn, brown is left hand turn. And then on the bottom, the red wire, which is the switched power. So power will be coming in from the back in through the blue, and then when you turn the switch on, it'll be coming back out through the red. The brown with a white stripe is the flasher. So this is the coming back in from the flasher. Brown with a white stripe basically is power to the switch for the turn signal. And then you have one more green wire here on the bottom right corner. That is, I see, that's your low beam headlight there. This green on the bottom here is a low beam headlight. So you can connect those up. And one thing I suggest, if you are testing this, if you have a bench power supply, I set mine to 12 volts, 5 amps, and then connect it to the power under the seat where the battery is feeding the circuit, and then you can test it for as long as you want without filling up your garage with exhaust. So I'm gonna set up the camera here and we can take a look at my wiring diagram, my modified one. So basically what we're looking at here is a diagram for the connector that we just reviewed. This is if you unplug the diagram and look directly at the end, how it is in the picture here. Then this is the layout for the wires, where the wires go. The top left in the picture is the pink, and that's the horn, or the peach, I guess. Top middle is high beam headlight. Top right is ground. Left middle is power in from battery, that's a blue wire. Center is right hand turn signal. Center right is left hand turn signal. Bottom left is power out from the switch. So when you turn on the switch that goes from low beam to high beam, if you pull that all the way down, that'll turn off the lights. When you flip it up onto either parking or headlight, then it will provide power to the switch, which will light up the tail light. The center bottom is a brown wire with a white stripe. It is power in from the flasher. And then the lower right is the low beam headlight. And the low beam headlight wire is the one that I have wired directly to the light bar that I installed. The main headlight is powered by the high beam wire, and the light bar is powered by the low beam wire. Alright, so that pretty much just leaves us with the overall wiring diagram. You've seen part of this already earlier. We've reviewed the wires coming from the alternator and the ignition pulse generator that go up and feed the rectifier, as well as the ignition control module. We've reviewed the wiring under the seat with the battery and the fuse, and the capacitor, as well as the voltage regulator. Now, there are voltage regulators there are rectifiers that you can buy with integrated voltage regulators. And so it would simplify the wiring here somewhat. I believe that the regulator or the rectifier that is under the seat on my bike now probably did have a voltage regulator in at one point. The rectifier still works. Apparently the voltage regulator does not. So ideally it would behoove me to replace that with a rectifier regulator unit, but it works for now, so I'm just going to leave it. We've talked about the rear light cluster. We have not talked about the brake light switch. The brake light switch basically just interrupts the wire that powers the brake light, and that is on the foot pedal switch on the right hand side of the engine. There's a switch that runs down the side there, and then it's I believe that just comes factory that way. It's a hydraulic switch. I bought the hydraulic unit, the replacement, directly from the dealer, so that's pretty simple. The other part we've talked about is the ignition switch and the engine stop switch. The engine stop switch is the typical one that you see on most two-strokes. I added a key as well so that I can simply turn it off, and then you can't start it unless you rip the ignition switch off, which basically it'll slow anybody down that wants to try to steal it, assume they just don't pick up the bike and carry it off. It's just a good deterrent to have, I figured, so I put it in. The engine stop switch, yeah, that's the standard one that's on the handlebar. So the multifunction switch, we've talked about that. The cable that runs back to the rear light cluster, and in the diagram here, you'll notice that where wires cross, or where the lines cross for the schematic that represent the wires, the only junctions, the only connections between wires are the ones where it shows the actual dot, the colored dot that indicates a connection. So from the multifunction switch, the wiring, it ran through that connector that we've already reviewed, and it talks about how it's wired up to the horn and the blinker, the flasher. The purple wire that comes off the switched power, that powers the horn and provides power to the blinker as well. So those are both hot. The wiring through the horn and the blinker are both hot, so you probably don't want it shorting out on anything. And the wires that go back into the multifunction switch are grounded out, or provide power from that from the lines going in the horn red line and the blinker orange line that go into the multifunction switch. And that provides power to the the right hand turn to be the green wire, which then grounds out, and then the left hand turn, which is brown. And let's see here, what am I missing? The light bar, yeah, so the light bar, like we've already talked about, the wiring from the multifunction switch for the high beam and the low beam go, I wired it up directly to the light bar. I just hijacked one of the lights from the typical 3-prong headlight. I hijacked the low beam and ran that to the LED light bar. I also made the mounts for the light bar, which that's a completely different video. This just covers the wiring. And yeah, I think that's pretty much it for this. So I'm going to leave links in the description. If you made it this far, thanks for sticking around. If you have any comments or questions, leave them below, and I'll respond to as many of them as I can. If you have any criticism too, I welcome that. Feedback, whatever. Leave a like if you found it useful, or give me a thumbs down if you thought it was trash. So yeah, take care, and I'll see you in the next one.